Christoph, and I would like to give the floor to Ivars Bergmanis, head of the Department of Remote Sensing of the Agency of Spatial Information, Latvia, who will be talking about the development of 3D model of the city of Riga.
Yes.
Okay, that's good. So I think you can see my screen. Or not?
Yes.
Do you see it? Okay, that's good. So hello everybody, thank you for inviting me to this meeting. I'm Ivars Bergmanis, head of the Remote Sensing Division in Latvia, in Geospatial Information Agency, and I will talk briefly about a project that we started in 2021. It's about creation of 3D models for Riga city. And we, as I mentioned before, we started this project in 2021, and we did our first, received the data, start our first test, did our first products. In 2022, we did most of our processing, and in this year we are finishing the projects and, so to say, publishing our current, the ones that we have created. And the main idea for this project was to create, so to say, a basic data that could be used for creation of a digital twin, where everybody can use it, where it can be used for different purposes. So, and it could be, so to say, server base for something bigger that we ourselves could create. So something for other agencies, other people to use. A little bit about ourselves. We are a small part of Latvian Geospatial Information Agency. We are at the moment 23 employees. We work in orthophoto sector and in the height model division. So, and yes, and about a little bit about my presentation. I will talk about, yes, the data acquisition and the data type that we acquired, the software that we used, and the products produced, and what is the current progress for it. What problems did we, so to say, encounter in the way, and what are our future plans and actions, some conclusions, and what is the current data availability for other people. And about the data acquisition, we were planned to obtain about 304 square kilometers in about area, but in the end we received about 500 square kilometers of data. The flights were done with oblique imagery and LiDAR. The image overlap is 80 to 60%. Image resolution is 7 centimeters, and LiDAR point density is 20 points per square kilometer, square meter. I apologize. And it all was done by an outside contractor, which okay. Sorry, nobody's seeing it. I just noticed. Right again. Why is nobody seeing it? I apologize for that. So, what do you see? You don't see it.
Please press F5.
F5, okay. Oh no, that's still, I see in the big screen, but you don't see anything. Am I correct? Yes. Okay.
Все бачимо.
Still.
It's okay.
We see everything. It's okay.
You see it? Okay. I'm just looking at the smaller screen and I don't see that you are seeing something. So now you see the big title, yes? Or not? Are the slides moving?
We can see, sorry, Ivars, we can see
No, it's okay.
slide,
It's all okay.
slides on the
It's okay, yes.
On the left.
Okay.
Can you press
I can
A5?
continue if everything's okay. Okay. So it was done by an outside contractor. It's MGP Aero. And the airplane that they used was paper PA 355 Chieftain. And the date was acquisition was done at about 920 meters altitude. And the date acquisition was between the 2nd of May and the 12th of May, in about 4 days. And about the imagery, it was done with five-phase Extreme 100 cameras. The oblique imagery was done with 70mm cameras, and the nadir was done with 50mm cameras. And in the end, we got around 80,000 images. The LiDAR data was done with a Regal LMS VQ 700 III scanner, and the final point density was around 40 points per square meter. The vertical accuracy was about 5.5 centimeters, and the horizontal accuracy was 22.2 centimeters. And in the end, yes, the program that we used for this data processing, we used a Trimble suite for the meshing and the orthophoto production, and TerraSolid solutions with Bentley PowerDraft for LiDAR point automatic and manual classification and creation of Load 2 models. And the products that we have created, we have the orthophotos with a final resolution of 8 centimeters. That are split in scale 1 to 2,000 tiles. Only RGB, no infrared in this project. The file format is TIFF, but we can use and create any other, so to say, format that the users are required. And we created some through orthophotos for some parts that we were required, and we also did fast orthophotos for the first task of processing. And this is a small example for this mesh model that we have created from all these images. This is the, so to say, at the moment final result that we have done, but we have gone through many more iterations. So there are, so to say, have been good and bad examples, and this is, so to say, the best one that we have gotten at the moment. And we have created this for the whole city, and we, so to say, plan to use these ideas and technologies in the future. But this is at the moment that we have what we have gotten out of this image, these whole images. So yes, at the moment, yeah, we have covered the whole city of Riga, and we are planning to expand at least, so to say, get the outside areas, so that every bit of data that we have, it has been used. And we provide this data in many formats that the users are needed, or depending what the programs what they are using. And about the LiDAR data, yes, it was also split in these 1 to 2,000 scale tiles. They are automatically and manually classified. The classes are, as usual, ground, vegetation, buildings, noise, overlap, water bridges, and other features where we put everything that doesn't fit in other categories. And all the points are colored by using orthophotos, as the scanning and imagery part was done in the same time. So we can get the exact information that we got in the same time. And yeah, this is a small example about the LiDAR data. We have created this in LAZ and LAS formats. We have created also from this data the digital elevation models, digital surface models, normalized surface models, and also contours for the whole city of Riga. And as you can see, there are not that many points on most of the walls, but we didn't really thought that we needed that much points. So we're mostly focused on roofs and ground level for this project. But yeah, all the points are colorized by the images, but we used all the images so that we can get the right colors even for the walls. So this is a little bit of this data. And we also use the data from the buildings and the ground and have created the level of 2 detail models. And also these are some of our results that we have gotten out of it. Okay. I just read the message that the presentation is not moving. Sorry, I don't know what is happening. Okay, I will try to just. I will try this one more time again. If we not, I'm just will finish, and then probably the presentation will be shared. Then everybody can, so to say, see it. And I will try to. Okay. What do we see? Okay, you see the slide with the building, so, but it's not. Oh, it's trying to move. Okay, the video is not moving. Okay, we'll try to jump. Well, so we have created the buildings for the whole city in many formats that people can use and access if they need it to. So, and yes, a little bit about the problems that, yeah, the main problem was it was quite a lot of data, slow data loading and processing times. Also, we used, so to say, many of our old automatic processing tools, and so we got a lot of buildings driving around the city where the buses and trams were classified as buildings. So that was a problem that we had to deal with. Also, yeah, we tried to get as many points on the buildings, and in the end, we got a lot of trees also classified as buildings so a lot of manual work will fix that. Also, this was for the first time that we were working with meshing add-ons, so we got a lot of, so to say, a small tsunami waves on the waters, and we couldn't fix it until the providers for the tools got some updates for us. So yeah, but we still have problems with some of the elements that are in the higher ups, so like wires and something like that, they get more information that they need to. So like towers and spikes are, yes, a little bit not that good looking at the moment. And also, yes, because we classified so many building points, we got a lot of more information than we needed, to, so to say, thin out a bit these points, because many buildings in the Riga Old Town are quite complex and do not show well in these models. And yes, about the data, we have delivered all this data to Riga City. They have their own GeoPortal where you can view and look at all this data. They have their own Load 2 and Load 1 models. Also, all this reality mesh model is available there. You can see it. Also, there's much more information if you need it. So everything is available there. And about the future, well, we still are in the final production phase, so some products need to be finalized. But the moment we are waiting reaction from the users, what do we need? Do we need more data? Do we need better quality? Do we need different products, different formats? No, everything else that we need. So we are trying to figure it out. And also we want to find out if it is usable, because this is the first time we are creating something like that, and we need to get as more user experience back as we can. And we are also planning for the future. Do we need, so to say, especially for Riga City, do we need to do it again? And what would be the intervals? Or maybe we should do it for other cities? That's still in the, so to say, the future and in the planning part. And with a little bit summary, yes, that acquisition is not that cheap, and it's not that easy, so to say, to process it by ourselves. And also it depends what the quality we got from the data. And the old tricks we didn't really work in our production stage, so we needed to learn some new things and to learn about some new products, because they come with new problems that we need, so to say, to clear out and finish what we can do. And there's still many questions about the future, but the main question is still open. Is it really, will this data be, so to say, a base for this Riga City digital twin? And what we maybe needs to create something more for people to use.
I'm sorry, Ivars, it's time to finish.
Lastly, about the data availability, the orthophotos and LiDAR are at the moment for a price, and we don't provide raw data, but the reality meshes and this Load 2 model that we have created, everybody can get it. So if you are interested in it, so you can just contact us and we will provide you with this data. And yeah, thank you for your attention and hope you at least enjoyed. What did you see from our presentation?
Дуже дякую, Ivars.